All right, this recording is for section 7.3, binomial radical expressions. Like radicals are just kind of like terms. They're radical expressions that have the same index and the same radicand. And so to add or to subtract the radicals, the textbook likes you to use the distributive property. That's not necessarily something that you need to do if you can understand. This is kind of like the square root of 7 is kind of like your x. And so if you look, you have 2 square root 7s, and you're going to add that to 3 square root 7s. So that means total, you're going to end up with 5 square root 7s. You have the same index, which is that term right there, since there is no term, it's the 2. And then you have the same radicand, which is the 7. If those two things are the same, you can add them just like you would like terms. Whereas if you look in letter B, 7 fourth root of 5 minus 2 third root of 5, the fourth root and the third root are not the same, therefore you cannot combine these. Now looking at letter C, you have 4 square root xy plus 5 square root xy. That 4 plus 5 gives you 9 square root xy's. Moving on, sometimes you need to simplify the problems to get down to something that you can combine. For example, the square root of 50 can be rewritten as the square root of 25 times 2. The square root of 32 can be rewritten as 16 times 2. And the square root of 18 can be written as 9 times 2. Now the square root of 25 is 5. You still have the square root of 2 inside. Plus, the square root of 16 is 4. You still have the square root of 2. And so I'm going to take 3 times 4, which gives me 12 square root 2. The square root of 9 is 3. Still have the square root of 2. And now I multiply 5 times 3, so minus 15 square root 2. The way the book has you look at this is to use the distributive property backwards. Since these all have the same index and the same radicand, the square root of 2, really it's 5 plus 12 minus 15, all times the square root of 2. So you take 5 plus 12, which is 17, minus the 15, so I end up with 2 square root 2. Now we can also multiply these expressions using the FOIL method. Can't just multiply the pieces because you lose that middle term. And so I end up with the square root of 2 times the square root of 2, which is 2. The square root of 2 times the square root of 3, which gives me negative square root 6. Do the inside as well, negative square root 3 times the square root of 2, negative square root 6. And then the outside terms, the last terms. Negative square root 3 times negative square root 3 gives me a positive 3. Now I can combine like terms. 2 plus 3 is 5. And I have 2 negative square root 6's. So I can rewrite it as 5 minus 2 square root 6. And you cannot combine those or simplify that any further. Taking that a little bit further, when you have the square root of 5 plus the square root of 7 and the square root of 5 minus the square root of 2, square root of 5 plus the square root of 2 and the square root of 5 minus the square root of 2, those are called conjugates of each other. And so when you have one plus and one minus, we learned earlier that those are the difference of two squares. So these two conjugates can be separated into a difference of 2 squares when you multiply those out. What that means is that this becomes the square root of 5 squared minus the square root of 2 squared, using that idea over there. And so as I look at that, the square root of 5 squared becomes 5. The square root of 2 squared becomes 2. So the answer to this is 5 minus 2, which is 3, which makes multiplying conjugates that involve radicals very, very simple. Now rationalizing the denominator of something that has this radical expression gets to be a little tricky. So we're going to start with the original equation, or the original expression. And anytime you have something that is added or subtracted, you have to look at using the conjugate. And so using the idea of what we just did in that last screen, we're going to multiply by the conjugate of the denominator. And the conjugate, again, just means that you take that middle sign and you switch it. And so when I do that, on the bottom, again, the conjugates, you just square those. So I get 4 squared, which is 16. I'll rewrite it out so that you can see what I'm doing. Minus the square root of 15 squared. Then you're going to FOIL out the top. 6 times 4 is 24. 6 times the square root of 15, so I get plus the 6 square root of 15, plus 4 times square root of 15. And the last step is the square root of 15 times the square root of 15 plus 15. So when I rewrite this, 24 plus 15 is 39. Plus, looking at combining the like terms, 6 square root 15 plus 4 square root 15 gives us 10 square root 15. 4 squared is 16 minus the square root of 15 squared is 15. So when I rewrite this, it becomes 39 plus 10 square root 15 all over 1, or just 39 plus 10 square root 15.